Okay, now we're going to talk about independent and dependent variables and functions. In the previous video, we learned about independent and dependent variables. We learned about how we can find them in equations, in relations. Now we're going to review what those terms are, and we're going to go over another example. Independent variables are variables of the domain. They can be any number. Dependent variables are variables of the range. This depends on the domain. Function tables will show you the table of the input, rule, and output, and that would look something like this. X, the rule, which let's say this is f of x is equal to x plus 4. So the rule would be x plus 4. And then f of x. And then we would plug in our x values. So x, let's say, is 0, 1, 2, 3. F of x would be the result. And the rule is x plus 4. So 0, 0 plus 4. 1 plus 4. 2 plus 4. 3 plus 4. And our result, our f of x, would be 0 plus 4 is 4. 1 plus 4 is 5. 2 plus 4 is 6. 3 plus 4 is 7. So this would be our function table. So let's take a look at this example. We're going to start by writing the function, even though that's step F right here. We're going to start with this step, just like they do in the video, just to keep things simple. And then we're going to do step E and D. So step F, write a function to represent the total sales. If we look at the example, a scrapbook store is selling rubber stamps for $4.95 each. The total sales, f of n, so f of n is total sales, that's something that we should write down. F of n equals, f of n is a function of the number of rubber stamps n sold. So the rubber stamps are $4.95 each, and n represents the number sold. So we can say that the total sales, f of n, is equal to $4.95 times the number of stamps sold. So $4.95 times the number of stamps sold. Or times n. Now, we have our function. We wrote it, write a function that represents the total sales, determine the total sales for 5 stamps. So we can say that f of 5, the function for 5 stamps, is equal to $4.95 times 5. So we can do this multiplication. 4.95 times 5. 5 times 5 is 25. Write the 5, carry the 2. 9 times 5 is 45. Add 2. 5 times 4 is 20. Add that 4. And we notice that there's 2 numbers after the decimal place in our multiplication. So we need 2 numbers after the decimal place in our answer. So our answer is $24.75 is the total sales for 5 stamps. Now part E and D. Part E, what values of the domain and range make sense for the situation? And part D, identify the independent and dependent variables. The independent variable is going to be the variable of the domain, and this can be any number. In this case, we're talking about stamps. So the variable in the domain is n, and n is the number of rubber stamps sold. So this number, our independent variable, is going to be n, the number of rubber stamps sold, It's going to be N, the number of rubber stamps sold, and that number is only going to be able to be a whole number. So 0, 1, 2, 3, 4, right? We're not going to be able to use decimals to represent the stamps because the stamps are only going to be whole numbers. They're only going to sell whole stamps. They're not going to sell parts of stamps. And the dependent variable is going to be the total sales. That would be f of n. That's the dependent variable. So that's part D. Part E, what values of the domain and range make sense for the situation? We already talked about the independent variable. That includes the domain, and we said that that can only be whole numbers. So the domain is going to be whole numbers because we cannot buy a fraction of a stamp. The range for this situation is going to be multiples of $4.95 because each stamp costs $4.95. So this is going to be multiples of $4.95. So if we buy one stamp, it'll be $4.95. If we buy two stamps, it'll be $9 and some change. So multiples of $4.95. So as the whole numbers change for the domain, the range will be multiples of $4.95. It's not going to be any numbers in between. It's just going to be multiples of $4.95.